All right, everybody. So we're still working through our first standard on matrix expressions and the different operations that we have with them. And this time we're going to be looking at, in video 11.1.3, our determinants. And determinants are used, so there's really no value to a determinant as a determinant, but it's used as we continue, and we'll be looking at matrix inverses, and then we'll be using these matrices to solve equations, and that's when they become into play. So as itself alone, a determinant, not so interesting. There are a few things that we could use it for, but mostly we're going to be using it when we solve. So just a quick checklist of the things we've done so far. We talked about the size of the matrices, and we talked about how to name them. We talked about adding, subtracting. We talked about scalar multiplication. We talked about matrix multiplication. What else did we talk about? Different operations, so adding, subtracting, multiplication. Yeah, that's where we're at. So in this video, we're actually going to be talking about determinants, which are very different. And so we're going to get started with that. But this is kind of like our checklist. There's only one more thing that follows this, and that is inverses. And we are going to be working inverses in our fourth video. So this really takes us through the whole first standard. We're almost there. So let's go ahead and get started. You don't need your calculator for this. We're just going to be working with some simple matrix by hand. They're not going to be very challenging. I will show you some operations that we can use a calculator for, but right now let's just stick with the pencil paper. So given a matrix, we know what these symbols mean. So this is first row, first column, first row, second column, second row, first column, second row, second column. That's what this means. To simplify this, we can also call this A, B, C, D, and call that our matrix, which I think it'll make it a little bit easier. This is a notation that it's explained in the book. Now, the determinant looks like absolute value symbols. It is not. When we use it with a capital letter and I take these bars, this is not absolute value. It appears that way, but it has no connection to absolute value whatsoever. So we would actually, if I see A, the determinant of A is written as this. Okay, so if matrix A, then the determinant A equals these bars with the A inside. Now, how do we find it? It's very simple. We're going to use multiplication in two diagonals. I'm going to grab a highlighter. The first diagonal is this one right here, and then the second diagonal is this one right here. So those are the two diagonals that we're going to use, and we're going to multiply. So I'm going to multiply A times D, and I'm going to subtract C times B. That means that the outcome is not a matrix. The outcome, the determinant, is a scalar. Remember, scalar means not a matrix. It means it's a simple number. So it could be a 7 or a 2 or a 1/2 or a -3. The outcome of the determinant, or the determinant itself, the outcome of this process is a scalar, not a matrix. All right, so we're going to give an example here. So we want to find a 2 by 2 determinant. We can actually only do this if the matrix is square. This is really important. You cannot find the matrix or the determinant if the matrix is not square. So 2 by 2, 4 by 4, 5 by 5, it has to be square. Find the determinant. We are going to multiply this diagonal together, and we get a 5. Let me change the notation. The determinant of this is technically -5, 9, 4, -1 with the absolute value bars, or these vertical bars. And then it equals the scalar, which is -5 times -1, +5, minus 4 times 9, which is 36. So 5 minus 36 is -31. So the determinant of this matrix, I'm calling it A because it didn't have a letter, is -31. All right, let's find the determinant of this matrix. Okay, and it doesn't say find the determinant because it already put the bars there, so it's already telling you that that's what it wants is the determinant. So if you don't see the word determinant, look for the vertical bars. That tells you that's what it's asking for. So this is saying that I want negative 5y minus 2x. So my determinant this time is negative 5y minus 2x. That is the determinant. Unless I knew what the value of the determinant was, I couldn't really solve for my variables, which is something we're going to do together in class. All right, what about a 3 by 3? Oh my, there's a lot of elements, right? There's 9 elements here. How are we going to find the determinant of a 3 by 3 matrix? Well, to do this, we actually are going, sorry about that, when we're actually going to use a different technique. There's a couple different techniques for this. I'm going to show you one of them, and that is that we are going to repeat the first 2 columns on the outside of the matrix. So I'm going to have A11, A12, A21, A22, A31, and A32. I'm repeating these columns on the outside of the matrix. Then what I'm going to do is I'm going to highlight diagonals. Oops. Let me undo that one. Okay, so I'm highlighting these diagonals. Okay, so this is my first kind of direction that I'm going to go. And what I'm going to do is I'm going to get an outcome of those. So whatever the product of this one is, let's say the product of this one is W. The product of this, I'm actually multiplying these numbers together. So A11, A22, A33 are all getting multiplied together. So you're going to multiply the columns, and let's say the outcome is W. Then I'm going to multiply this column, I said diagonal, and you're going to get an X. I'm just supposing. And then I multiply this diagonal, and I get a Y. That means that I'm going to take the product of the products that I've got, W plus X plus Y. Now, step 2 seems a little confusing when there's just variables, so don't worry, I've got a real example here with numbers coming up. So the next one, I'm going to go this direction, and I'm going to multiply those together. Okay, so if I multiply these together, then I'm going to get 3 different outcomes. Okay, products, I'm just multiplying that diagonal all together. So that means I'm multiplying A31 times A22 times A13. And let's suppose when I multiply those together, I get M. And when I multiply this entire thing together, I get N. And when I multiply this entire diagonal together, I get P. So I'm going to have M plus N plus P. So I'm just adding together those, and then I subtract these quantities. What's important is that you come up with this one first, and you subtract the other one. So let's try this together, because that might have been confusing. Alright, so let's give this one a try with numbers, and let's see how it goes. The first thing I'm going to do is I'm going to rewrite my matrix in the determinant manner, which means I'm going to have vertical bars 1, 2, 0, negative 1, 2, negative 1, 0, 1, and 4. And I'm going to repeat the first 2 columns, that is 1, 2, negative 1, 2, and 0, 1. And now I'm going to use the highlighter. I'm just going to demonstrate this, that I'm going to be multiplying these 3 diagonals all together. So that looks like this. So when I multiply all of those together, this gives me 8, 0, and 0. So I'm going to add together 8 plus 0 plus 0. Okay, now let's go the other direction. So I'm going to change my highlighter color so we can go the other direction. And that is I'm going to be multiplying this way. So the results of that are going to be a 0, a negative 1, and a negative 8. And I'm going to add those together. 0 plus negative 1 plus negative 8. So this all together is 8, and if you go ahead and add these together, I have minus a negative 9. So the outcome, my determinant of A, is 17. So hopefully that makes sense. We'll definitely get a chance to practice more of these together, and I am going to show you an option of using your calculator, but it is important that we can do these by hand, because if there are variables, we have to be able to do this by hand. So great job on these, and we'll just keep moving. You guys are doing awesome.